Now, a point is 30 mm behind VP, 30 mm above HP, and 25 mm in front or behind or from LPP. Draw its projections and name the side view. So the condition of this point is behind VP and above HP. The condition of behind VP and above HP means it is in second quadrant. So that is the origin. Behind VP, it is on the minus side because it's on HP, that is the horizontal distance. So the horizontal plane will be on the minus side, and above HP, from here this is 0, so it will be above HP will be on VP, so the vertical plane will be on the positive side. So minus on the x-axis, plus on the y-axis, minus comma plus, so you're going to get the second quadrant. So this is one way of explaining, and since the condition is behind VP above HP, which we have already explained in the second quadrant, so the point will lie in the second quadrant. Now we are going to take that example. A point capital P which is in space is behind VP. So this distance will going to be the behind VP distance. When you look from the top view, the image will going to fall on HP. So this will be behind VP distance, which is 30 mm. And 30 mm above HP, when you look from the front view, the distance above HP, which is 30 mm, which can be seen when it is on the vertical plane. You can see that it will be on the vertical plane. The distance of 30 mm above HP is seen in the vertical plane. Now 25 mm in front or behind or from LPP. From the video of projections of points in the second quadrant, we have detailedly explained the condition of behind VP. So obviously it should be behind LPP. So behind LPP means we have to look from the left side view, because in the left side view, if you consider the behind LPP, the plane is between the object and the observer. This will going to satisfy the conditions of the front view always, because always profile plane will be in line with the vertical plane. So when you are seeing the condition of the vertical plane, if you look from the front view, plane is between the object and the observer. So this condition satisfies only in the profile plane when you are looking from the left side view. So when you look from the left side view, the object is behind LPP. So behind LPP distance is seen when you look from the top view, it will be on HP, and when you look from the front view, it will be on VP. So that distance is 25 mm. You can see the distance of 25 mm from here to here, that is from this from LPP to the point is 25 mm. So that distance which can be seen from here to here, that is from this endpoint to this front view image, and here also from this point to the top view image. So this is how we can explain the three-dimensional image on the projections of points in the second quadrant. Now when it is cut here and open such that HP is rotated to the top and LPP towards the left side, which you can see, the images which also on the respective planes is also being get rotated here, which has been shown. This is the intermediate rotation of the plane. When we go to the next slide, when you can see here in the step 3 that the HP is rotated by 90 degrees, so that both VP and HP will be overlapping with each other, and LPP on the left side. Now the distance behind LPP is seen in both HP and VP, so that distance is 25 mm here. The distance above HP, which can be seen in vertical plane, so from here you measure the distance of 30 mm and you mark that point, which is P dash. The distance behind VP, the distance behind VP is also 30 when it is rotated to the top side. So since VP and HP have been overlapping, since the point of behind VP is also 30 mm, so both will going to overlap here. Since P dash is the one which will be the vertical plane which is fixed, so it is written outside the bracket. And since P is also overlapping, so here since the HP is the one which is rotated, therefore you make that image of P, which is the top view image, in bracket. Then when you look from the left side view behind LPP, which is seen in behind LPP, where you can see the distances of both front view and also the top view. So draw a vertical projector from the front view into the profile plane directly, and then also your top view point onto the end of the horizontal plane, and then draw a 45-degree line wherein the vertical distance of behind VP is transferred into horizontal distance of behind VP. Then when it is projected upwards, so that both front view and the side view will be on the same line, so we are going to get the intersection point here. So this point will be considered as P double dash, and name that point as the left side view, because left side view will satisfy the condition that it is behind LPP. So P double dash will going to be the left side view. So this is how, when the planes are rotated and the respective images will be on those planes, has been explained. Now we will going to solve the problem in a sketchbook of this particular type of problem. First we will going to draw the XY line and X1 Y1 line, which is as shown with the thin lines, and he has given the LPP. So write LPP on the left side of X1 Y1 and mark VP and HP above XY line, because both vertical plane and the horizontal plane will be above XY line here as per the step 3. So you mark this point VP and also HP. HP is the one which has been rotated, therefore you keep it in bracket. Now first condition is the distance behind LPP, which is 25 mm. First you consider that distance. You mark from X1 Y1 line, you measure 25 mm from X1 Y1 and draw a vertical projector, which should be a thin line. The distance above HP of 30 mm is seen in VP. So from here you measure the distance of 30 mm and mark this point, which will going to be P dash. So that is the image which you can see in the front view. Then the distance behind VP is also 30 mm. So from XY line you mark 30 mm, and since the behind VP distance is seen in HP, so since the HP is the one which is rotated, therefore the image what you see in HP is the top view, so you keep this in bracket. You mark this point P, small p, in bracket. Then the distances of both front view and top view is seen in the profile view. So draw a horizontal projector from the front view to the profile view first. Then since we need to transfer the distance of the top view, so draw a 45-degree line adjacent to the top view. Draw the 45-degree line adjacent to the top view. Since HP is above XY line, so from the origin you draw a 45-degree line and then project from the top view, that is from P, draw a horizontal projector such that it will go to meet the 45-degree line, wherein the behind VP distance of 30 mm, which is vertical, is transferred as the horizontal distance, which is 30 mm now. So where the position of the front view, on that line you are going to get the side view. So since P dash is on the same line as in P, so this will going to be the point wherein you will be able to find the P double dash. So since it is the left side view, because it is behind LPP, that condition is satisfied only when you are considering the left side view. So P double dash will be the left side view. This is also quite evident from here. Instead of drawing a 45-degree line here, if you draw a 45-degree line here, then what happens? This P dash and P double dash both will be on the same line. This is actually a square. Instead of drawing this diagonal, we are drawing this diagonal here in this point. So this will going to be the final solution for this particular problem in the second quadrant.